Everybody, welcome back to another fun and exciting Algebra 2 class. In our last lesson, on lesson 4.8, I was not able to complete the whole lesson. It's a really long lesson, lots of stuff packed in there. So I'm going to do a part B to that lesson right now. I'm going to start on page 206. Page 206. The first thing I want to show you is right here. It's converting to standard form. So let's say our parabola, our equation's not in standard parabolic form, and we need to get it into that form. Well, how do we do that? How do we accomplish that? Well, the way that you accomplish it is by basically creating a perfect square. And we'll talk about that in just a second as we work through this. The steps are there on page 206. I'm not going to write the steps out. I'm just going to kind of go through them with you as we go through this. Okay, so the first thing that you really want to do is you want to separate this out. Separate out your quadratic term and your linear term. Okay, so put parentheses around the quadratic and linear terms. Now, the book says there to factor out common factors, but that's not right. That's not exactly right. Okay, I believe that that's a little bit of a misprint there. What you would do if you were factoring out common factors is you would take out the x, right? Okay, but we're not going to factor out. So maybe write in your book right there. You can write on step number 2, factor out numerical factors, the numerical factors, okay? So if you have a common number factor, then you'd factor it out. This one does not have that, so we'll just move on. But if you ever have one that has a common numerical factor, you'll take that outside, okay? But leave the x in there. You need the x's there. All right. Next thing we want to do is we want to determine, we want to look at this and we want to say, what would make that a perfect square? What would make that a perfect square? Well, if I had this, x squared plus 2x plus 1, this is now a perfect square. X plus 1, x plus 1. Basically, I'm kind of factoring it without the final term in it, and I'm saying what would the final term need to be if this was going to be a perfect square. In this case, it would need to be a 1. So what I want to do is I want to add 1 to it. Okay, so you know enough about equations that if I add 1 right here, I have to add 1 to the other side, right? So I'd have to add 1 over here. Well, there's a problem with that. We have the function of x over here. We don't really have anything to add it to. See, this is standard form, so we don't want to put something over on that side. Let me show you what this would look like. So if I add 1 over here, then I would subtract 1, or I would add 1 over here. Now, you'd end up with function of x plus 1. Well, in order to simplify that out, right, because we can't have that, that's not standard form, we would have to subtract 1 from both sides. Now look over here. I could subtract it from this side, I could subtract it from that 8 right there. So you can look at it that way if you want, or you can look at it this way. Let me kind of show you a little bit, maybe like a shortcut to that. If I add 1 here, remember we're keeping it balanced. So if I add 1 here, I need to, it's on the same side, okay? So it's like I have a stack of money in my hand, for example. And if I take 1 out of this stack that's right here, but I want to keep this side the same. I don't want to add anything over here because I don't want it to get out of balance. So if I add a penny over here, then I would need to take a penny away, okay? So if I add 1, I also need to subtract 1. Does that make sense? Yes, technically you'd be adding it over here, then in the very next step you'd be subtracting it over here and subtracting here. So I'm just kind of saving you that step of subtracting it from both sides and then, having to do it again. So however you want to look at that is fine. But then we would end up with a negative 9 over here. Keep that in parentheses right there. We're keeping that in parentheses for a reason. Why are we doing this? Because we're trying to put it into standard form. What standard form? Well, let's write it over here. The function of x equals a x minus h parenthesis squared plus k. All right, so this is our standard form. I don't want you to get confused of what we're doing here. So here's why I separated that. Look, now I've created an h right there, and now I have a k right there. So we're getting close. We're not quite in standard form yet, but we're getting there. What else do we have to do? Well, we had to get this squared out here, because look, the squared is outside of the parentheses. Well, how could we do that? Well, we can factor this. What is this factored? X plus 1 squared. So basically we took that square outside of the parentheses by factoring it, minus 9. And so now we are in standard form. The function of x equals x plus 1 squared minus 9. Not an easy process, but once you get it, I think it'll start clicking to you. You're like, oh, okay, I get it now. Okay, that makes sense. What you're trying to do, the biggest thing that you need to remember is you're trying to create a perfect square right there. You're trying to take this right here, the quadratic and linear term, and you're trying to turn it into a perfect square. This is a lot like completing the square, but it's just a little bit different because we actually leave that over on this side here in this process. But it's very similar to completing the square. All right, so there we go. We got it, and now we're in standard form. So that's how to take an equation of a function that's not in standard form and put it into standard form. We need to make sure that we know standard form right here. Make sure that you get your a, x, h, and k. In this one here, this one does not have an a, or it does. Technically, a would be 1, so a equals 1. The h in this one is going to equal -1. But you say, but look, it's a positive one. But don't forget, our standard form has a negative in it. So we have to make that a -1. And then our k is -9. And you say, wait, we have to change that sign too. No, we don't. Because look, our standard form is just a positive k. So that the k stays the same. The h is the one that changes signs when we pull it out. Okay? So there's our A, H, and K. Those are very important things for you to have. One reason is because the vertex is H, comma, K. So the vertex of this one is -1, comma, -9. That would be our vertex for this one. So in other words, we'd be moving it to the left 1 spot, okay, and then we'd be moving it down 9 spots when we set it up, okay. All right, next thing I want to show you real quick is it's on the next page, page 207. It is the parabola vertex formula, the parabola vertex formula. So you need to memorize this right here. -2b over 2a, that's our x, okay? Because remember, we're looking for the parabola vertex, and this is our y. The function of -2b, the function of -b over 2a is our y. So you say, well, I don't understand that. Well, what if you say, well, why don't I just look for the h and the k? Because the h and the k is my vertex. You're right. But what if it's not in standard form? What if you don't feel like putting it in the standard form? What if it's hard to put it in standard form? Okay. Well, then you can do it with the parabola vertex formula. This is another way to find the parabola's vertex. So if I go down here, I take the function of x, I'm just going to give an example, equals x squared minus 8x plus 12. Now we could we could change that into standard form the way that we just did. But let's say we don't want to do it that way. Let's say that we want to use this formula right here. So now we're going to take this formula, -b over 2a. -b over 2a. Let me change that color there so it's easier for you to see. -2, -b, there we go, over 2a. Now, I want to plug in. You say, what's my a and my b? I've seen an a, but I don't know what the b is. Look, this is a quadratic, okay? So this is our a, this is our b, and this is our c, right? Okay, a, b, c. So you should remember that from quadratics. So our -b, so that's going to be a -8. So that's actually going to come out to a +8 over 2a. What is A? A is 1. 2 times 1. So 8 over 2, and that equals 4. So our x in this one is going to be 4. So let's write that over here. We'll write our vertex over here. So I'll write vertex. All right, so this was our first one that we found was our x. Because remember, we're going up here. This is the formula we used right here. The 2 negative b over 2a. That's our x. So we got 4. So our vertex is 4 something. We don't know what the other part is yet. What does the other part say? The other part says this. It's the function of negative b over 2a. What does that mean? Well, it's the function of this. Or in other words, you have to, once you solve that, then you can add in the function. So let's erase some of this stuff. What was the solution to this right here? What was the solution? It's 4. So now we want to find the function of 4. How do we do that? Well, everywhere there's an x, we're going to put in a 4. We're going to find the function of 4 now. Equals 4 squared minus 8 times 4 plus 12. That's how you solve this, okay? So the y is the function of x. What is x? Negative b over 2a. What did that come out to? It came out to 4 right there. So now we're going to plug 4 in everywhere that we see an x and then solve that. Okay, so what do we do next? We just work our formula, okay? 4x squared. What is 4x squared? 16 minus 4 times 8 is, or 8 times 4, 32 plus 12. All right, so the way that we would do this is we would have 16 minus 32, so that's positive 16 minus a 32, and so that's going to give us a negative 16 plus 12. Negative 16 plus 12 is negative 4. So our y in this case is going to be negative 4. So our vertex is 4, negative 4. 4, negative 4. And that's using the parabola vertex formula. Okay. All right. The last thing that I want to do is I want to show you how to graph a parabola, and this is very, 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 very important as we go forward in math. In this class, your next classes, your college classes, anything, you're going to need to know how to graph a parabola. I'll show you a little shortcut too, but we'll take the long road here so that you just kind of get the steps down, and then at the end I'll show you a little shortcut that you might like to save you some time. All right, here's what we're going to do. The first thing we want to do is we really want to come over here and just make one of these, remember these little charts that we used to do for X and Y? Remember those? Okay, where we just plug in a number. Yeah, we're going to do that right here. Yeah, except for this one, we can call it the function of X, right? Because that's our Y. That's our output. So we have X and function of X. And now, so you don't just want to throw in any random number. And let me show you what I mean by that. Here's what you first want to, here's the easiest way to do this. First of all, let's find the vertex. The vertex is very easy to locate in this one because our vertex is HK. So what's our vertex? Well, it's positive 1 because remember we have to change the sign on that. So it's 1, negative 3. There's our K. So there we go. Our vertex was really easy. You could write your vertex in right here. 1, negative 3. Okay? So that's our vertex. Now, I've got some steps written down here. Steps to graph a parabola. The first step is find the vertex. Check. We did that. That's easy. I like that one. Okay, what do you do if it's not in standard form? Well, you use the parabola vertex formula that we just talked about right up here. Okay, so you could use that negative b over 2a. Use that, no problem. Okay, all right. Graphing the parabola, step number 2. Now, this is kind of a complicated step, but I think you're going to understand it once we do it. I wrote down here, choose x values, 1 away to the right and to the left of the vertex. All right, so what does that mean? What do I mean by that? So let's say that we have a graph here. I'll do it in a different color so it doesn't confuse you. Okay. Right now, our point is at 1 on the x, right? Our point is at 1 on the x. Now, it's at negative 3 on the y, but I'm just saying it's at this 1 positive. Okay, now, I want you to choose one position to the right. So what would that be? That would be 2 on the x. And I want you to choose one position to the left. What would that be? That would be 0 on the x. Okay? And there's a specific reason I want you to do that, but you just got to trust me right now. So choose one position to the right and one position to the left. Okay? And so here's what we're going to do with that. Whoops, I wanted to leave that. All right. So here's what we're going to do. Now we're going to come through here. We can erase all this stuff because we've already got this down. We've already got the vertex written down. Now we want to plug in these two numbers. Now the cool thing about these two numbers is because it's a parabola. Okay, so here's our line. One cool thing about the parabola is that it matches. Notice that it's the same as we go up. Okay, it matches all the way up. In other words, it's going to be the same on both sides of our vertex. You'll see what I mean in just a second. We plug in the number 2. Watch what happens. So now, everywhere that you see an x, you're going to plug in the number 2 because that's what we're testing. So it would be the function of 2 equals 2 minus 1 squared minus 3. What is 2 minus 1? Okay, 2 minus 1 is 1. 1 squared minus 3. 1 squared is 1. 1 minus 3 is negative 2. So this one's going to be a negative 2. Okay. Now I want to show you what happens when we plug in the next one, the 0 that I've got there in the box. All right, so now let's plug in the 0. 0 minus 1 is negative 1 squared minus 3. What is negative 1 squared? Well, it's positive 1. What's positive 1 minus 3? That equals negative 2 again. So our 0 is also negative 2. Now there's a reason why that happens, and it's right here. That square causes these two x values to be exactly the same on the y. In other words, that's what makes our parabola. That's what gives our parabola the U shape. Okay? It's basically matching. This one is matching this one. It's the same distance. It's what gives it that nice U shape on the graph. Okay? All right. So now what we're going to do is we're going to do it one more time. Well, let's go down and look at the steps here. Repeat step number 3. Repeat step number 2 with x values 2 away from the vertex. Okay, so now we're going to come over here and we're going to go 2 away from the vertex. So let's start it again. And now let's do 2 more x values, 2 away from the vertex. So again, if we have our vertex is right here at 1, and these are x values. So we went 1 away, that's the 2. So now we're going to go 2 away. So what is that? 1, 2, well, 1, 2, 3. So we're going to be at 3, and let's go the other way on that. So now this is our vertex, so we're going to go 1. Now we're at 0, negative 1. Okay? So now we're at negative 1. So these are the 2 new x values that we want to try. Okay? So now we're going to plug, remember these are going to match each other because the other ones matched each other. The parabola keeps its nice little U shape right here. And what do we do here? Well, we plug these in. So 3 minus 1 squared minus 3. 3 minus 1 is 2. 2 squared is 4. Minus 3 is 1. So that's going to be at 1. And the next one's going to be at 1, 2. 1 as well, not 1, 2, but 1 as well. I'll do that one for you real quick. Negative 1 minus 1 squared minus 3, negative 1, negative 2. Negative 2 squared is 4, minus 3 is 1. So this one's 1 again. And that's going to come out the same every time when you kind of match them up. When you take the same number on both sides of the parabola, it's going to keep coming out the same. Now what we want to do is we want to graph this. And I'm going to graph this right here, and I'm going to try to do it at least somewhat organized so that you can see it, but it's not going to be perfect, okay? So what we want to do is we want to come down here. We want to start off by graphing the vertex. That's this guy right here. So we're at 1, negative 3. So we're going to have 1, 1, 2, 3. So our vertex is going to be right there somewhere. Now we want to graph the next one. And so we're at 2, negative 2. So we're going to go 2 spots, negative 2. And then we're at 0. So we're back here and we're right there, negative 2. So now we're going to graph this one right here, 3. So we're going to go 3 spots, and then we're going to go 1 up. So the next spot's going to be right here, and then we're going to go negative 1, and then 1. So basically 1 up. So we're going to go right there. If you notice, when we take and we draw in our U shape, we want to draw, and it's hard for me to draw in here, but you want to draw a nice, neat, smooth curve. And again, it's kind of challenging for me to do, but there we go. That one's decent. Okay, and that is our parabola. Now let me show you something that's interesting. You can graph this parabola. I told you I was going to show you a shortcut, and I know this is a really long video, but I want to show it to you. Here's the shortcut for graphing this. Once you find out the vertex. Let's go back here to the vertex. All right, so let's erase all these extra points right here. So we've got our vertex graphed, okay? All I have to do is, this is the way it's going to work. We're going to go 1 over 1 up. 1 over 1 up. That's the first section. The next section goes 2 over, okay, from where it was, 1, 2, and 4 up. 1, 2, 3, 4. There we are right there. And the same thing. 1 over, 2 over, 1, 2, 3, 4 up. And the reason it does that, and there's our curve again, and I'll erase some of this stuff. So if you can think of it in terms of 1 over 1 up, 2 over 4 up. The reason it's doing that is because and the next one would be 3 over, and then we'd square that, 9 up. Okay, and so you're squaring as you're going. The next one would be 4 over 16 up. So the first one is, so basically you go over 1 and then you square it that many times up. And that's what's happening right here, is this square. So it's a little bit of a shortcut. If that makes sense to you, you can graph like that. If it doesn't make sense to you, then do it the other way, because you're going to get the right answer if you do it the other way too. And it takes a little longer, but shortcuts are always good. So there you go. There's a shortcut. All right. Oh my goodness, that was a long lesson, 25 minutes. I'm so sorry. But I needed to get that into you. Hopefully you learned something there. If you didn't, make sure to go back and rewind it. I know it's a long lesson, but make sure you go back and rewind it. This is important stuff for your test and for other math classes that are coming up, okay? All right, we'll see you later. Bye-bye.